Okay. Good morning, good afternoon, good evening, everyone from wherever you are joining us. I am Jason Walls from QA Cafe and the Purple Marketing Committee. And we like to put together these webinars from time to time to show you the latest on what Purple is working on, the latest about the technology that's building into the Purple project, and meeting the great people behind it. And speaking of the great people behind it, I have Cihangir with me, who is one of the Purple Foundation software architects, who is working directly on prplMesh, and has a lot of updates about EasyMesh R6 and prplMesh, and how prplMesh is implementing it and the consequences for anyone who wants to be putting it into their products. Um, so before I hand things off to him, I do want to mention we are using Zoom for this webinar, obviously. Um, do, do, do. People saying there's some echo. Hold on, let me get rid of the noise removal. That should be a little better. Okay, yes, we are using Zoom for this webinar. So during the Q&A session, if you would please use the Q&A control panel in your Zoom control, and that will let both of us see your questions pop up and we can sort of triage them. But please feel free to ask them while the webinar is going on. If it ends up being like super relevant to what Jahangir is talking about, then then we'll try to address it. Otherwise, we'll get it to the end. All right. Without any further ado, I will turn things over to you.
All right. Hello, everyone. My name is Cihangir, and I am prpLMesh Program Manager, and we are going to talk about today implementing EasyMesh R6 with prpLMesh today. Okay, what do we have in our agenda? Today, I will try to cover what is EasyMesh and what EasyMesh R6 brings in. And also, we will discuss later on what is prpLMesh stack and architecture and our prpLMesh 6.0 release, our testing coverage, deployment scenarios, next releases of prpLMesh, the prpLMesh working group, and how to contribute. All right, let's dive in. What is EasyMesh? The Wi-Fi EasyMesh defines standardized protocols for onboarding, configuring, controlling, and managing the Wi-Fi mesh networks. And the Wi-Fi Alliance defines this EasyMesh specification and also certification program for it. And EasyMesh is built on IEEE 1905.1. The EasyMesh has a functionality for topology management, telemetry collection, channel management, steering, topology optimizations, traffic separation, and QoS in general. And it also supports different generations of Wi-Fi, including 6, 6E, and Wi-Fi 7. I tried to cover the most relevant or important features that EasyMesh R6 brings. I will not talk about too much about the details, but generally, I want to talk about is the first thing is early AP capability detection. With this EasyMesh R6 version, now extenders and agents are sending their early capabilities to the controller so that controller can see what is this device, what is it capable of. Is it supporting Wi-Fi 7? How many simultaneous links is supporting? Or is it supporting BSTA or only APMLO? All these details are shared before onboarding procedure so that controller can really decide which settings to be propagated. So this is the first change, the early AP capability. And later, the biggest change is the multi-link device support, MLD support for access points and the backhaul stations. So this allows us to configure APMLO, BSTA MLO, the every combination we need to create any APMLO group in the mesh network. And also it defines 6 GHz standard power spectrum availability handling and EHD informations. So these last two sections are actually is useful to understand the availability in the 60 GHz band for you to do better channel management. Especially you can select your channel puncturing bitmap according to these feedbacks with this spec. Okay, EasyMesh also have linked features in it, like the Wi-Fi DPP Easy Connect, QoS management, data elements. All these are also defined by Wi-Fi Alliance. They are incorporated on top of EasyMesh. So you are not only getting EasyMesh spec and also linked features with it. And all the slides I shared in the beginning are from the Wi-Fi Alliance technical overview page. You can access this reference by registering the Wi Fi Alliance page and download it, even the latest spec. Okay, that's it generally about EasyMesh spec itself. And I want to explain the organization's overview here. So to give you a better understanding how Wi-Fi Alliance and Purple Foundations stands. So the Wi-Fi Alliance develops interoperability specifications and certification programs for Wi-Fi technologies. And Purple Foundation develop open source implementations of those standards. Also contributes to evolution of adaptation of next generation of networking technologies. So these two organizations are actually complementing each other. And there will be some updates from the foundation LinkedIn page that we will give even more news about this collaboration with Wi-Fi Alliance and Purple Foundation. Okay, we covered EasyMesh, and now I will start discussing then what is prplMesh. Okay, prplMesh is actually full Wi-Fi stack. In the name, it looks like it includes only mesh, but it is not. The prplMesh is a stack name. It contains multiple components in it. For example, we have prplMesh EasyMesh controller, agent, EasyMesh R6. We have prplMesh wireless hardware manager. We have Wi-Fi sensing application, and we have data model mapper. We will talk about those in next slides. And in particularly for mesh application, it is open source carrier grade implementation of Wi-Fi Alliance EasyMesh standard. It is portable, compliant, and superset of EasyMesh. Works on any Wi-Fi SoC via abstracted Purple low-level API, and it is deployed since 2021. And where is this stack? I added our Purple Foundation's GitLab link. If you click there, you will see the right page. It contains every related component under the prplMesh stack. We have PWHM, EasyMesh, Wi-Fi sensing, data model mapper, and some complementary tools under this repo. So what is accessible today? So you have full access to our source code, our wiki pages, documentations. But what you don't have an access if you are not a member is Jira tickets and merge requests. So you cannot raise a merge request unless you're a member. Okay, I added here a prplMesh architecture. I will not deep dive too much, but basically if I start from the left side, this is the gateway. In this gateway, if I start from the bottom, we have PWHM component, wireless hardware manager component, and this component communicates with the lower layer, host API, open source host APD, and WPS applicant via control socket. And also we have NLA211 to the Linux wireless framework, again, open source. And underneath we have vendor wireless firmware or hardware, which is not open source to us. But basically PWHM uses only open source and low-level API compliant APIs to configure host APD, WPS applicant, and NLA211. The PWHM exposes the device Wi-Fi subtree, like access points, SSID, endpoint, radio, any local Wi-Fi management handled by the PWHM. And these data models are exposed to the local bus. On top of it, we have prplMesh agent. This prplMesh agent has an abstraction layer and let's say HAL to communicate with PWHM via TR181 data models, just like device Wi-Fi data models. The prplMesh agent directly uses them to communicate whatever controller sends over 1905 as a command or status. The 1905 message arrives to the agent, and agent converts it to the BWL layer and apply the proper data model of PWHM. And also we have Wi-Fi sensing application alongside with it. Sensing application also talks to PWHM over data model. On top of that, we have a data model application. This data model mapper communicates with each application, provides subset of device Wi-Fi, talks to them, and converts it and map to the USB bus as a single device Wi-Fi entity. So this guy is only responsible for the communicating the USB bus. Okay, so this is the gateway side, and extender side, it is almost similar, but instead of having a controller inside, we have a 1905 network. That controller provides the same 1905 messages to this guy, and agent is again using the BWL and applying the same data models to the PWHM and low-level driver. And in the right section, we have non-mesh scenario. And in this case, you don't have an EasyMesh deployed, but you still have the PWHM component for Wi-Fi management. You still have TR1 AOT1 compliant data models. You can still run Wi-Fi sensing, and you can also use data model mapper to expose your data models. All right, this was our general architecture. And now I want to talk about our prpLMesh 6.0 release. What do we offer in prpLMesh 6.0 release? So the prpLMesh 6.0 contains an EasyMesh R6 certifiable gateway profile. We have an in-house Wi-Fi Alliance testbed, and we are passing the test for R4, R5, and R6, especially for gateway profile. In extended profile, we are about to pass R6, but the full tests are not covered yet. It will be mentioned in the next release topic, but the extended BSTA-MLO support is also there. But currently with this release, 6.0 release, we have a gateway profile certifiable. Even if we are certified in 6.0, we also have some features from 6.1, especially most wanted from our members is WPA3 compatibility mode. So we also support compatibility mode from the 6.1 spec. We are also compliant to Airtie's EasyMesh Plus TLV extensions in agent. And we are also supporting AP-MLO, BSTA-MLO, and STA-MLE data models in controller. And with high-level API support for with data model I just mentioned over USB and RBus. Okay, so I just want to mention how are we performing the tests and validate our releases. So this is our test coverage that we have multiple test beds. As I mentioned, the Wi-Fi Alliance test bed, we have R1, R4, R5, R6 in our Belgium office, and we have Airtie's Orbit data verification suite, and we also have Huawei Cafe CD router with Wi-Fi 7 testing, and now we are getting Alitia's Wi-Check testbed. Will be delivered within this year. So we are using these testbeds to cover the most of the Wi-Fi testing and coverage. And we also have different testing infrastructure and stack. One of them is prpLMesh CI is the board farm. We can implement our own mimicking 1905 instead of running full Wi-Fi Alliance test. But if you want to just check some behaviors with 1905, you can just emulate some 1905 frames with this board farm. And also we have prpl CI that the CRAM infrastructure allows us to run some tests based on command line tools, just like set some data models and check how it behaves kind of action, like data model by data model, you can run some tests with this CRAM infrastructure. Okay, so we discussed about the prpLMesh, our testing coverage, our release, and now I try to gather different deployment scenarios which may applicable to you, some of them. Maybe some of them are just not applicable to you. So I try to gather as much as I can. So maybe I couldn't cover everything, but you will see that I try to get different deployment scenarios. Okay. The first scenario, this is the most wanted by us, full prpLMesh deployment. It contains all the components. It is completely aligned with our low-level API requirements. EasyMesh R6 compatible, as I mentioned, it comes with prpLMesh 6.0. It is interoperable with other R6 extenders. It doesn't have to be prpLMesh, of course. There is no limitation there. We are also supporting Airtest TLV Plus in this. We are supporting topology optimization and channel management through data model. So the controller exposes data models so that you can perform any optimization you may want. The configuration is device Wi-Fi templates here. So the device Wi-Fi template recently added data model in the 2020, I believe, that allow us to configure different sets of settings for the mesh topology. As I mentioned in the EasyMesh spec, EasyMesh R6 features that the early AP capability. Now it really fits in with this device Wi-Fi templates, so you can define your configuration per device. So for example, if one extender tried to pair to the gateway, and this extender is dual band, so we understand it from the early AP capability. And with this device Wi-Fi templates, you can define sets of settings could only be delivered to the dual band extenders. And you can define another settings only applicable for tri-band. And you can also define something only for MLO supported extenders. You can even add some Mac OUI handling to detect your own extenders to deploy a different sets of settings. So device Wi-Fi templates is a very powerful data model. Please check it. We highly suggest you to use this and utilize this. And it is also development of the in the prpMesh controller as a controller configuration API now. And controller also exposes device Wi-Fi data elements. These data elements are used for status to reflect the network, the mesh topology, and every information you need. And also it can receive some commands like channel selection, steering, and blocking a station, apply a MAC filter rule. So the device Wi-Fi data elements also used for delivering some commands to the controller. And we also now support device IEEE 1905.network data model. So this is also fairly new. It is actually was old but adapted again. So it is the data elements specifically focused on Wi-Fi networks. But if you want to reflect wired stations, not 1905 neighbors, maybe not Wi-Fi stations, now represented in this 1905 network. So you will have data elements, full Wi-Fi mesh network topology, and with this 1905 network, you will also see the wired and again wireless 1905 neighbors will be reported. So you will have full visibility over the mesh. And this stack requires to own full Wi-Fi management. So what I mean to say that if you are trying to deploy the stack on OpenWRT, for example, the PWHM and low-level side needs to be owned completely by the stack. So you cannot run additional Wi-Fi management here. So you need to use data models for management additionally. So this owns full Wi-Fi management. So if I go over the chart here, I try to simplify the architecture from the earlier page. So we have a controller receives the configuration from templates. We expose data elements, 1905 network. All these commands translated to agent with 1905, and then agent talks to PWHM with the BWL layer, as I mentioned, and also agent talks to Wi-Fi sensing with BWL for mesh operations. And this sensing and PWHM also talks to each other. The PWHM exposes device.Wi-Fi. The PWHM delivers the configuration, the lower layer side with CFG and NL802.11 and host APD, the direct socket access to the host APD and WPS supplicant. And also, just one note that prpMesh agent also has a direct low-level API link here for bridging tools, that IP tools to activate the VLAN IDs for traffic separation. And for QS, we are using Linux TC. Okay, so as a benefit, you will get full foundation work if you go with this scenario one. Okay, scenario two. In scenario two, it is very similar to the first one, but the only difference is maybe you don't support device Wi-Fi templates. So especially when we talk about this new data model set for configuration to the operators, they got some goosebumps. Why? Because it means that they need to change their cloud, maybe mobile applications, web UIs to go with this new data model. It is frustrating for them to update these kind of big infrastructures, which is very old. So what they prefer sometimes to still manage the settings with old TR181 data model, device Wi-Fi. In this case, we have a scenario to support this. What we are doing is we drop the templates here. The controller subscribe to this device Wi-Fi data model. If you modify some settings over web UI, for example, controller is getting a notification for these local settings, copy those and updates it to all agents in the network. So you try to set your settings in local device, but it automatically copied to all mesh devices in your network. It is simple, but it's also complex because, as I mentioned in the Wi-Fi templates, you lose the capability of distributing different settings. Now you are entitled to only one entity, device Wi-Fi, and it will be copied to all devices. You cannot differentiate per device, one downside. And another downside is if you look the picture, there is a circular dependency here, so that agent is also trying to set some same data models, but you are also using as a configuration source. You need to be careful on this, but we still support it. Some operators still relying on it. So this is also another deployment scenario. Okay, the scenario 3, in this case, we have standalone Wi-Fi. It is only PWHM and maybe Wi-Fi sensing. This only exposes device.Wi-Fi for your management. It is simplistic. Maybe you don't need extender support, but still you can use Wi-Fi prpMesh stack without mesh. So it will give you the benefit again of foundations work in the low-level API side and PWHM level. And maybe you can think of that you want to deploy your devices without mesh support with this configuration method, and maybe you will enable EasyMesh as service if they purchase extender. So there are some operators using this method. They don't want to increase RAM usage before they ship the device, and they just activate the mesh later in time. So you can consider the standalone mode in this perspective. Yeah, I think that's it for this one. Okay, so the gateway scenario 4. The orange color is used for third-party applications, not our Purple Foundations, but any other company's third-party application. So in this scenario, some companies replaces our controller and put their own controller on top of our stack. You will still get the same benefit as lower layers, PWHM and prpMesh agent, but only difference is controller. So we cannot guarantee that this controller's northbound API support. So that's why I just put the data elements as a little bit cleared. So we cannot guarantee the northbound API side. But what would be the motivation about this is maybe you have some internal logic in your controller, and maybe you're embedded to cloud APIs that you cannot change your controller. You can still use it. But normally what we suggest, don't go with this direction. Instead, use prpMesh controller, add your the management service on top of prpMesh controller and use northbound API instead of replacing the controller, because now you are taking some responsibility on your own stack. But this is also valid scenario. Some companies also use that, so that I also added this. Okay, so the most complex one, the one that we don't suggest the most is again with the prpMesh stack with different abstraction layer. So this, you are still using our controller, or maybe again third-party controller. You are using our prpMesh agent. So if you are using our controller, you still get the same data models, APIs, benefits, and agent is there. Agent is still using the low-level API for bridging and QoS functionality. For this time, maybe you cannot replace Wi-Fi stack. Maybe it is not low-level API compliant. Maybe you have some sort of dependency. So the prpMesh design is flexible enough for you to design or define any BWL. But when you do that, you take, again, full responsibility on yourself in the low-level API side and the Wi-Fi management side. We cannot guarantee anything else. It can be done, it is supported, but not suggested by us. Okay, so we have last gateway scenario. Maybe this is the one that least used, I can say. But we also saw that the different kind of deployment, that you have a device, it has everything, EasyMesh agent, third-party Wi-Fi, and driver is unknown to us, let's say, but you still want to deploy your solution with an EasyMesh controller, and you need a controller, basically. You can just get our controller and put on this EasyMesh on top of EasyMesh stack. We call this controller only mode. We are not officially supported because we don't have these kind of third-party devices at all. But we know that some companies deploy this way. It can be done, but again, the responsibility complete is on the integrator. You can make it work, but you may need to invest a little bit if you want to go with this direction. Okay, I think we covered most gateway scenarios. Now I added one extender scenario. So the extender is actually similar what we have for gateways. It is not that different. Only difference is the controller is outside. I added here as a remote controller. Why did I say agent? Sorry, it's a typo. The remote controller, and in this case, the 1905 frames comes from Ethernet ports or Wi-Fi to our agent, and agent behaves as before. There is no difference in extended profile, but I want to add specifically the extended profile in one purpose. This extended profile is also tested in Wi-Fi Alliance, uh, and we guarantee the interoperability with other mesh gateways. So the prpMesh extender doesn't have to work with prpMesh controller at the end. If you have some gateway already deployed with some other custom stack, you can still choose your new extenders to be the prpMesh based. So you still get our benefits from the foundations work and low-level API compliance, but still you can keep your own gateway, which may be deployed on field already. So we have some work with other communities also for interoperability of our extender profile, and prpl itself offers an extender profile for minimal purpleware image that we get rid of some of the applications we don't need in gateway, ideally to be an extender. So this is also actively worked on in purpleware scope to reduce the memory and functionality as an image. And it also supports BBF auto provisioning. All right, and maybe one more note that this extender also support Wi-Fi sensing. So the most of the extenders today, I don't think the Wi-Fi sensing is the default application provided in the extender. So if you're interested in mesh-wise Wi-Fi sensing, you can also consider purple mesh-based extenders. Okay, I think I covered almost most of the deployment scenarios. Now I want to talk a little bit on our next release. So in our next releases, we are targeting to add some functionality. As I mentioned that we are certifiable for gateway profile. Now we are working on missing pieces in extender profile. There are some interoperability issues we face for beast-time alone mainly, but we are about to solve them. We will get this certifiable soon. We are adding the AFC support with EasyMesh. We are adding DPP Easy Connect support soon. As I mentioned, Wi-Fi sensing over EasyMesh is under development right now. We are going to add TID to link mapping will be added soon for QoS functionals of R6. And we are working on 11B and UHR support. Another name is Wi-Fi 8. The basic Wi-Fi 8 support we are working on. And we are also working on coordinated push button pairing right now for easier pairing process for extenders. Okay, so the prplMesh working group goals. So as I stated, our first goal is having a reference implementation of EasyMesh. Second is the platform independence. So any operating system with the recent Linux kernel can use the prplMesh stack. And advanced purple foundations, carrier interest group, low-level API recommendations, and cooperation with open source communities like Linux Wireless and Host API community, cooperation with standard bodies like Broadband Forum, OBMap, and Wi-Fi Alliance, cooperation with wireless silicon vendors, stable purple mesh on all of our reference platforms. So we have in a Purple Foundation, we have multiple reference platforms, maybe mentioned in the previous webinars. We have a different reference platform levels like fast track, regular track, and we have a reference platform for almost every silicon vendor. And we are actively deploying and testing Purple Mesh on them. So if you are going to talk to them and if you are going to ask them, are you supporting Purple Mesh? And you will get the answer yes, because we are already testing those in our reference platforms and they're actively supporting those activities. And we are also at the end allowing solution vendor differentiation. So I will mention a bit on this one. In prpLMesh working group, we have different calls to discuss different topics. Some of them are weekly, some of them are bi-weekly, some of them are annually. So we have architecture call, status call, Wi-Fi sensing call, PWHM call, 11BN roadmap call, testing and certification review call, and prpLMesh Summit technical day meetings. This picture actually from the last year's Paris technical summit. Okay, I talked a lot of stuff. Now let me summarize. Why should you choose prpLMesh? So first, foundations development and support. You will get any benefit that any of our members bringing features or operators adding the features to the stack, you will automatically get. Aligning with the new versions of EasyMesh spec. So we are R6 now, but we are already started working on analysis of next EasyMesh release. So you will always get the latest version. So follow our roadmap and focus on new generations of Wi-Fi. As I mentioned, we already started working on 11BN and 11BF. Low-level API targets to have interoperability and porting with different silicon vendors. So we are trying to solve the biggest problem for you to deploy different chip vendors or silicon vendors to have a same functionality. So our low-level API targets mandates them to follow. If they are going to get low-level API certificate from the foundation, they need to align with these rules and suggestions from us so that each different silicon vendor at least support what we ask from them. So get benefit from our testing coverage with our reference platforms and technical support from our experts. Okay, so as a summary, I added a prpl ecosystem. In the left side, you see the first gateway profile that I mentioned. It is full prpMesh stack. And this left side, as I mentioned, that controller exposes templates, data elements, and network, 1905 network. Wi-Fi sensing exposes device Wi-Fi sensing. The PWHM exposes device.Wi-Fi. Our purpose AI infrastructure team is working on a new data model for device.ai to be able to use local NPU in the fast track platforms. And all of these data models are put in the Northbound API section. These are all APIs, the data models. In the right side, we have an application layer. And if they are following our prpl LCM requirements, they are containerized secure applications. So I gave a couple of examples here. There is no specific order here, but let's say, hypothetically, you want to have a mesh management software in your system. You can download this containerized application to the system, which can communicate to cloud. What it needs to do is just to talk to controller data models, templates, data elements, and network to obtain any information it needs or set any configuration it needs over those APIs. Similarly, maybe you want to deploy Wi-Fi sensing application in your devices. So this sensing application can talk to mesh to understand topology. It can directly talk to Wi-Fi sensing data models and device Wi-Fi. And it can even use device AI data models to do some local calculation in the MPU. So this third-party application can live freely here. We can have QS manager, the parental control application, security application, device identification application, and maybe power management application. You can imagine any application you want. So what we are telling basically, instead of investing the left side, put your energy in the right side because the left side, it is already common problems. We are trying to solve the biggest problems for you in the Wi-Fi management, and this management, the tools will give you the right data models and APIs so that you can deliver your value-added services. Instead of wasting your time solving these problems with the chip vendors, whatnot, just use prplMesh, just ask a platform with low-level API compliant, and instead just focus on the application layer, value-added services. So this is fully shows what prplMesh promises you. So I don't want to say we are perfect, we don't have any issue. It's not like that. Of course, this is a software. There will be some bugs, and there will be features we need to add, etc. So, but let's be a member of this project, invest in it, improve it, like add your features, fix some problems, so that everybody has common, stable, lower layer management in the left side. And when you try to deploy your application, you can simply ask, are you supporting prpMesh 6.0? If they say yes, and you can immediately ship your application on top of it. You don't need to worry about what was the compliance on this chip. Is this driver working as expected? What is the Wi-Fi is behaving, etc., etc. So this is solving a lot of problems with multiple vendors in multiple deployment scenarios in different countries, etc. So this is our general ecosystem, what we are trying to support here. Okay, I think that was my last slide, and now I give the microphone to Jason.
All right. Thank you, Cihangir. Yeah. So we want to make sure that everybody knows how to get involved with this project. As we're saying, the best way to be able to make sure that even some like we have some good questions coming in, by the way. So if you want to go ahead, Jahangir, and open that and take a look at some of those because I want to address the fact that, if there are questions that people have or ways that they think things should be working or things that haven't been implemented yet or features that people want to see, the best way to see them happen is to become a member of Purple Foundation and contribute to the work. There are several membership levels available that you can find on that website. And by being active in the working groups and contributing to the open source projects and coming to meet us at the summits, which is also very fun, you can help drive the direction of where this is going beyond everything that's already been done, which is an amazing amount of work, I have to say. Yeah, so I would love to open this up to questions now. So we have like a bunch that have already come in. If you want to
Okay,
take a
I
look
can
at a
see the
few of those.
questions, but do I
Yeah.
need to show these questions to audience as well, or
No,
should I read it?
no,
Okay.
you just go ahead and just say it out loud.
Okay, so there is one question from Tim Spets, for my ex-colleague. So, is Wi-Fi sensing supports over Wi-Fi the data elements or only device Wi-Fi native? So right now it supports device Wi-Fi native today, but the foundation right now is working to add Wi-Fi sensing to the next EasyMesh spec. So especially Walter Clutton's, our principal architect, is working heavily on it to add it to the next EasyMesh release. When it is being added, possibly it will automatically come to the data elements as well, team. So it is on roadmap, I can say. Okay, so let's move on to Stefan Kolker, also my ex-colleague. Hello, Stefan. So scenario one, without any extender, switched on is also standalone gateway. So it doesn't make sense to go to scenario three. Let me go to the scenarios. Uh, okay, so we don't need to go to scenario three for sure. But we are just suggesting if anybody wants, without a mesh, maybe they don't prefer to onboard any extender, and maybe they don't want overhead, maybe memory usage, maybe they don't need this data model usages, whatnot. They can use it. I don't see also much benefit. Only go with this mode. But possibly there are some use cases for others, so they I added as optional. Actually, it's not a mandatory thing. Yeah. All right, for Laxman Pulmati, also my ex-colleague. Hello, Laxman. The question was, does scenario one supports full TR181, TR69 data model? Okay, in this, right? In scenario one. Okay, so as I mentioned, our data model mapper converts all of these DMs to be accessible by TR369. I cannot say it supports everything. It shouldn't. It will not. It will not be fair, but it supports most of it. And if there are some missing data models, you can always report so that we can take it and implement. So even some companies suggest and implement their own data model. I cannot say everything is implemented, but most of it is implemented, Laxman. Okay, we have another question from Simon. Is it correct that WPA3 compatibility mode is supported, but the mechanism propagates the security mode from controller to agent as EasyMesh R6.1? So, okay, so you are right. The compatibility mode is not part of 6.0. As I mentioned, let me maybe open that release section here. So we are not only 6.0, I can say, and we are some features already from 6.1 ported on prplMesh, especially required by our operators, and the WPA3 compatibility mode was one of them. It is not breaking anything in 6.0 spec, but it brings only additional feature. Maybe this will answer. Okay, so Laxman also asks, is there any support for Mac randomization? That I don't know, Laxman. I need to check that and get back to you. Okay, we have a question from anonymous attendee. Wi-Fi sensing agent is from community as well. Yes, it is. So maybe I will go to the scenario again. The Wi-Fi sensing application is not doing any classification. This Wi-Fi sensing application just for the providing to API so that Wi-Fi sensing applications directly communicate this data models instead of going with driver and do some operations. Again, it is just a northbound API so that any Wi-Fi sensing application can get and fetch CSI data, whatever information they need. So it is a default open source Wi-Fi sensing application today, yeah, by the community. Okay, Anil is asking also from my ex-colleague, hello. Does prpMesh provide sample LCM applications to demonstrate the usage of Wi-Fi templates? So I don't know that answer, Anil, but I believe right now when we exposes the data model to USB bus with data model mapper, any LCM containerized application can access to it. As far as I know, maybe Jason can comment on it. But this is what I know, Anil. Yeah.
Yes, the answer to that question is yes. If so, for people who aren't familiar with the way that containerized applications are being worked on through Broadband Forum and Purple and the LCM project and Working Text 492 and a bunch of other things. The idea is that a third party application comes in, uses USP internally over the bus to communicate with the USP agent that there's new functionality, um, new data model functionality. It takes ownership of that functionality. There's a registration process and a whole bunch of other mechanisms that make sure that two people aren't trying to do the same things. And then the agent then knows that it has this new functionality, it reveals that to any USP controllers, and then everything should work.
Okay, we have a question from Ashok. Ashok, you're asking about the WAN interface types. In that perspective, I don't have much in-depth knowledge. Maybe we could ask this to a little bit the low-level API side and the router pollutants that I cannot comment right now. Sorry, it's not in the prpMesh working group scope, but possibly the right address is low-level API group and the Purple OS working group for this. Okay, we have a question from Ahmet Atakan. Is there any deployment at any ISP or is there any plan to deploy? Yes, there is definitely. Maybe Jason, you can comment on it. It's marketing information that you can share, maybe.
Well, the official ones, if you've seen the ones from Orange in various locations, you've seen those out there. I don't remember which other ones have actually announced, sort of like in public news, but yes, the answer is definitely yes.
Yeah. So Atakan, the thing is, the deployment started years ago with Wi-Fi 6 products. Now, especially with prpMesh 6, most of the members of our foundation are planning to ship their Wi-Fi 7 devices with this prpMesh 6.0 stack together. So for Wi-Fi 6, it is already deployed, definitely. For Wi-Fi 7, now being deployed with these releases, for sure. There are some chat messages, but they are not using the QA section. Maybe they
Yeah,
are
I moved
aware.
everybody who did ask a message in the chat. I asked them to move it over to Q&A. I think we're all caught up now. If anybody does have any more questions, please do put them in the Q&A control panel. I know one question that we get all the time is this video going to be made available and will the slides be made available? Yes, definitely. We'll be putting this on YouTube, and if you consented to be contacted by Purple Foundation and the panelists, then yes, you will get a copy of the slides. Otherwise, no, we cannot violate GDPR to give you the slides.
Okay. Okay, so there's one question from Michael. Hi, this is Mike, and I would like to know that if prpMesh get any plan to support Qualcomm, new open source Wi-Fi driver for new platform. So right now, maybe I forgot to mention that here. So in the section that why should you choose the prpMesh, our reference platforms. Maybe we need to touch a little bit. So right now we have the Qualcomm Fast Track platform and the Maxineer Fast Track platform, and we have MediaTek Regular Tech platform, and Broadcom Regular Track is on the pipe. So we have almost every silicons being added as a reference platform to the Purple Foundation today. We are already supporting Qualcomm open source and newest open source drivers, yes, and also we are working to get the latest one for 11BN support, Michael. The answer is yes. And when you become a Purple Foundation member, you can purchase any reference platforms to your internal testing and deployment. You have right to purchase any reference platforms.
Right. Oh, this is very efficient. Oh, here's another one.
Okay, Vinay. Does prpMesh handle with local optimization logic developed by CP vendor. Okay, so maybe I will come here. As I mentioned, our controller is written in a way to accept commands. We have some local optimization developed years back in the prpLMesh controller, but we don't maintain it actively because the prpLMesh controller is also an API for your logic to do the optimization. When you boot right now the prpLMesh stack, without any management tool, the topology optimization and channel management is not done by anybody. You need to do this over the APIs that we are supporting, like data elements. So if there is a local logic, definitely it will interop with them. As long as these interoperability are coming with data elements APIs, like standard APIs or 1905 messages, especially if you have an extender, let's say, prpLMesh extender, and let's say you have an Arcadian gateway. As I mentioned, this one of the extender deployment scenario. It will definitely work because these 1905 frames are standard. EasyMesh guarantees that. Okay, Laxman, can you talk briefly about using Banana Pi for testing prpLMesh? Is it scenario one or available? So the Banana Pi is not our official regular track platforms, Laxman. But we have Arcadian's Mozart platform based on MediaTek, almost same as Banana Pi, with a very similar simple effect or simple effort. You can port the current MediaTek delivery on the Mozart and port it for Banana Pi. But because of this is not an official board, we don't support it and we don't test it. And because it doesn't have proper antennas, calibration, it is not really gateway ready device, right? It is just for testing platform. You can deploy prpLMesh to it. It is easy. You can use it, but it is not in our official testing environment. So you need to do some adaptation with from Arcadian's Mozart platform with MediaTek to this Banana Pi. Okay, we have one more anonymous question. How much an effort is needed to make prpLMesh integrated with OpenWRT? So it depends. How it depends is if, as I mentioned in the deployment scenario one, if you are going to get rid of current OpenWRT's Wi-Fi management, native ID, I believe, and if you try to port complete stack, it should be straightforward. But if you want to define a different BWL or maintain host ABD and NL802 11 directly, you need to spend some time on it. Yeah. Okay, Ali, from Ali Kızıl, are these resources to read the benefits of Purple to telco operators are over the live deployments? Are there resources?
Yeah, some they're asking if we have any resources for sort of explaining the benefits that people can hand off. And I had Ali put this into the Q&A so that I can make sure that I follow up with a couple of those things. And that is if that's something that everyone finds is valuable, then it's definitely something we can send out to the webinar attendees who consented to be contacted.
I think the resources should be this webinar, basically, for at least in prpLMesh. So for the
For real,
purple
right? Yeah.
yeah. So for purple OS,
Yeah.
I believe there should be more other slides or webinars that maybe Jason can point to. I don't want to talk about only the full purple OS and purpleware deployment. I just want to mention prpLMesh. This has everything you need. I think explains most of the things. Okay. How?
Yeah. This is really great. Thank you everyone for all these questions. These have been pretty in-depth. But if there's nothing further, Cihangir, is there anything else you wanted to mention?
I was not expecting to finish that fast. Did I
Yeah.
forget anything? I'm just thinking, did I forget anything?
No, I don't think it was
Um,
even that fast given the amount of questions we had. It was pretty great.
Okay, we discussed the platforms, our ecosystem. I think it is straightforward, right? So this
Mhm.
prpLMesh ecosystem explains everything what we need basically. And maybe we can mention here that you don't need to even deploy containerized application here. You can directly write a cloud application to communicate with TR369 so that you can use these APIs and still send the same commands over cloud. You don't need even application in the device, basically, right? So it also supports this cloud APIs to be used, northbound API, then high-level API, allows multiple deployments of services.
Yeah. And
Okay,
that's actually a really good point because, outside of the entire containerization thing, for the third-party app developers, as long as, if everybody's familiar with the way that USP is designed, the multi-controller architecture, with permissions and everything that comes with it means that this scenario on the right is possible, right? So a third
yeah,
party can control just Wi-Fi sensing if you wanted to, or just
yes.
the deployment and initial setup or things like that.
Yeah, access level control on data models, I think. Yeah, what you are referring,
Yeah.
yes.
Yeah. Yeah.
Okay, we have one more question from Mihal. The next release will try to support 11BN. As far as I know, Wi-Fi Alliance will release this EasyMesh R8 and expected to release this 2028. So what is the prpMesh plan for the next release? Is there any timeline and the watch features? Okay. So in that sense of 11BN support, we are planning, what we are focused on today is to start from the bottom. So as you see in the screen, right, we need to first make sure that the low-level APIs, NL802 11, host APD, and kernel are capable of handling 11BN deployments. So we are not focusing on mesh first. We are focusing on standalone 11BN support in the beginning, especially maybe at the end of this year. We would like to start activating basic UHR support and the standalone mode in the device Wi-Fi level, not in the mesh level, to activate this feature. And when EasyMesh specification gets mature along the way, we will start also implementing this as part of EasyMesh spec. But it is hard to say right now today because, as you mentioned, it is under development. But we have an active calls. We are following those discussions and we are part of it. So whatever being decided in the Wi-Fi Alliance calls, we will immediately take this and implement it as a next step. Is device Wi-Fi sensing proprietary extension? No, it is an open source prpMesh application. The proprietary one is the Wi-Fi sensing service in the right side. The application is proprietary, but the data models and Wi-Fi sensing APIs are exposed to anybody.
All right. Great. Thank you everyone for coming. And we are trying to do at least one webinar a quarter. The things to look out for in the future are especially the Purple Summit 2026, which is going to be in Vienna concurrently with NetworkX. So please do look out for that. And which is really great because we get to meet you all. And we go into some pretty on the tech day goes into some pretty detailed stuff on the updates on everybody's projects and things like roadmaps and stuff like that. So it'll be good to see. All right.
All right.
If there was no other questions, then thank you, Cihangir, for doing this. We know it's a lot of work, and we will be sending this out to the people who can receive it and look for this on YouTube and look for our next
Uh,
webinar.
Jason, somebody's asking in the chat that where they
Oh,
are going to get this recording. I think you just mentioned that it will be posted to YouTube, right?
the video will be on YouTube, and the presentation will be PDF'd, and we'll send that out over email to people who have consented to be contacted.
All
All
right.
right.
Thank you very much.
Thank you, and we will
Nice
see
to
you
see
all
the
soon.
all old names. Thank you for attending. You make me happy, and I miss you all.